Last time we talked about rational functions, and we talked about how you can find different parts of rational functions, whether they be intercepts, whether they be where they are discontinuous, whether it's a vertical asymptote or a hole. We also talked about the horizontal asymptote or slant asymptotes, which indicate the end behavior of the graph. Today we're going to put all that together and graph rational functions. So we're going to be doing 4 examples, and we'll apply everything that we learned last time to graphing. Here's example 1, x squared plus x minus 12 over x squared minus 4. The first thing you want to do is you want to factor both numerator and denominator if possible. So in this case, the numerator factors to x plus 4x minus 3, and in the denominator, this factors to x plus 2x minus 2. Now, let's start with finding the horizontal asymptotes. Let's compare the degree of the numerator and the denominator. In this case, they are the same, so that means we are going to divide the leading coefficients. Dividing the leading coefficients, we have y is equal to 1 over 1, which is equal to 1. So we have a horizontal asymptote at y equals 1. Next, vertical asymptotes. These are anything that make the denominator equal to 0, but not the numerator. So that would be x equals 2 and x equals negative 2. Holes, anything that shows up in both the numerator and the denominator as a factor. In this case, there are no holes. The y-intercept, this is when you set x equal to 0. So we have 0 squared plus 0 minus 12 over 0 squared minus 4, which is equal to negative 12 over negative 4, which is positive 3. So our y-intercept is at 3. The x-intercept, this is when you set your numerator factors equal to 0. And so we have x equals negative 4 and positive 3. Now I've left this last part here as more points, and this is just if you feel like you don't have enough information to sketch your graph, you can always plug in more points. Let's start with what we have. So we have a horizontal asymptote at y equals 1, so I'm going to draw that in. We have 2 vertical asymptotes, one at x equals 2 and one at x equals negative 2. So we'll draw both of those in. Now there are no holes. We have a y-intercept at 3. I'm going to draw that in. So on the y-axis at 3, there's a point. And then x-intercepts at 3 and at negative 4. So on the x-axis, I'm going to draw a point at 3 and at negative 4. Now you might feel like this is not quite enough information for you to draw your graph. The more practice you get with these, the more likely you'll be able to sketch the graph without necessarily needing more points, but in some cases you'll need more points anyway. So I'm going to draw a little table here, and I'm going to say, okay, I want to know what happens when x equals 1. So at x equals 1, you plug 1 into the equation, and you end up with 10/3, so about 3 1/3, 3.3 or so. Plug in 4, so now I'm plugging in a point that's on the right-hand side of both of those vertical asymptotes. Plug 4 in, we end up with 2/3. And let's plug in a point that's on the other side, so negative 3 on the left of both vertical asymptotes, and we get that y is equal to negative 1.2. Now we can put those points in to help us, so 1 and 3.3 repeating, and then 4, 2/3, so it's a little bit closer, and then negative 3, 1.2. Alright, so when you go about sketching these graphs, remember that your graphs can never cross the vertical asymptotes, but they can get very, very close to those vertical asymptotes. Horizontal asymptotes, it is possible that they cross, but really the horizontal asymptote is just telling you what the graphs look like at the far ends. So it should also get very, very close to, sometimes it does touch or cross, but it's going to look a lot like this line, y equals 1. So I'm going to draw this picture out. This part goes towards those vertical asymptotes, going up. And then this last part here, it's getting closer and closer to that line, y equals 1. So again, never cross vertical asymptotes, and then horizontal asymptotes are a guide as to what the graph looks like at the far ends of the graph. Let's look at another example. -4 over x squared minus 3x. We are going to go ahead and factor out the denominator. So x squared minus 3x becomes x times x minus 3. Horizontal asymptotes, you're comparing the degree of the numerator and the denominator. In this case, the degree of the numerator is smaller than the degree of the denominator, so the horizontal asymptote is automatically y equals 0. Vertical asymptotes, anything that makes just the denominator equal to 0, so x is equal to 0 and 3. Wholes are anything that makes both the numerator and the denominator 0. In this case, we don't have anything. We will do an example where there is a whole, so you can see what that looks like. Y-intercept, we are plugging in 0 in for your x value. And that actually gives you 4 over 0, which is undefined. So what you'll end up seeing is because we have a vertical asymptote at x equals 0, we actually don't have a y-intercept. X-intercept, anything that makes the numerator equal to 0. In this case, there is nothing. And you'll notice that in this case we had a horizontal asymptote at y equals 0, so it actually means that it's never going to cross that horizontal asymptote. Let's graph what we have. So y equals 0, that horizontal asymptote. Our two vertical asymptotes at x equals 0 and x equals 3. All right, and it looks like we don't have any other information. So this is an example of where using a little chart, a little table, and plugging in more values will help you sketch your graph. So let's say I want to know what's happening kind of at each section of the graph. So let's start with x equals 1, that middle section. So when x equals 1, and you plug that in, we have 4 times 1 squared minus 3 times 1, and then tack on a negative, and you get y is equal to 2. All right, let's try when x equals 2. We have -4 over 2 squared minus 3 times 2, so 4 minus 6. -2, 4 divided by -2 is -2, and that's going to be 2 as well. Okay, now let's see what's happening on other parts of the graph. So let's say when x equals 4. When x equals 4, plug that in. We end up getting -1. All right, let's try the other side of the graph. Let's say at -1. Plug that in, and we get -1. All right, let's plot those points. So we have 1, 2, 2, 2. Kind of have an idea of what that might look like. All right, we have 4, -1, and -1, -1. Again, remember the horizontal asymptote tells you what the graph looks like at the far end. So if that helps you draw your function, you should start there. So this function is going to be very close to the horizontal asymptote, and then it's going to get very close to the vertical asymptote. And then in the middle there, it's going to be going up. And on either side, it's going to get closer and closer to those vertical asymptotes. And then on the far right there, on the very far right, for the end behavior, it's going to get very, very close to that horizontal asymptote again. And then on as it gets closer and closer to the vertical asymptote, it should get closer and closer to that vertical asymptote. All right, example 3. 3x squared minus 12x all over x squared minus 2x minus 3. Let's start by factoring. So 3x times x minus 4, and on the bottom we have x plus 1 and x minus 3. Let's start with the horizontal asymptote. So comparing the degree of the numerator and the denominator, they are the same. So the asymptote is going to be the quotient of the leading coefficient, so that's 3 over 1, which is equal to 3. Vertical asymptotes, anything that makes just the denominator equal to 0. In this case, that would be -1 and 3. Wholes, anything that shows up in both the numerator and the denominator to equal 0. In this case, we don't have any. the y-intercept where you set x equal to 0. So we have 0 over negative 3, which is equal to 0. X-intercepts, anything that makes the numerator and only the numerator equal to 0. So that would be at x equals 0 and x equals 4. Let's put everything that we have so far onto our graph. So our horizontal asymptote at y equals 3. And then we have vertical asymptotes at negative 1 and positive 3. No holes. We have a y-intercept at 0. Plot that. And then we have x-intercepts at 0, which is the same as the y-intercept, and at 4. All right, so we have some information here, but probably not enough for us to draw a picture of this graph. So again, let's just plug in some more points, pick points that are in different sections of the graph, and plug them in. So let's say when x equals negative 2, since we have nothing over on that side right now, y is equal to 7.2. Okay, so that gives us a pretty good idea of what's happening. So the more you do these, probably the fewer points you actually need to put in. Once you have negative 2, 7.2, and you graph that, you probably have a pretty good idea of what that graph is going to look like. It's going to get very close to the vertical asymptote, and then get very close to the horizontal asymptote. Now, you can always plug in more points, so negative 3 gives you 5.25, and so on. Now let's go on to the middle section. We know there's a point at 0, 0, but let's say we plug in 1 just to see what the behavior of this graph looks like. So plugging in 1, we end up with 2.25 for y. Plug in 2, we get 4 for y. That's probably enough for us to draw a good picture of the graph in that middle section. All right, in the last section there, we already have that point at 4, 0. Let's see what happens as you go further along. Again, the more that you do these, the less likely you'll need to put in as many points, and you'll be able to use the points that you already have and be able to say, okay, it gets closer to the vertical asymptote here and closer to the horizontal asymptote here. But just for practice, putting in some more points, let's say you put 5 in. At 5, you get 1.25 for y. And putting in 9, we get 2.25 for y. All right, let's put those points on the graph. And now we have a pretty good sketch of our graph. Right, so we have this section here. Again, notice at the far left, it gets closer and closer to that horizontal asymptote. And then as it gets closer and closer to negative 1, the graph is going to get closer and closer to the vertical asymptote while going up, while increasing. And then in this middle section here, now remember I said horizontal asymptotes can be crossed. Horizontal asymptotes are more of an indicator of what's happening at the far ends of the graph. So particularly here, this can absolutely cross, and on either side, it will get closer and closer to the vertical asymptote. And then on the far right section here, again, the horizontal asymptote indicates what's happening on the far right side of the graph, and you can see the shape of the graph taking form from these points, and you get closer and closer to the vertical asymptote as you move to the left. All right, we have one last example. 2x squared plus 10x plus 12 all over x squared plus 3x plus 2. Let's factor. So it looks like in the numerator we can factor out a 2 first, and then factor that to x plus 2, x plus 3, and on the bottom that factors to x plus 1, x plus 2. Horizontal asymptote, compare degrees. The degrees are the same, so we find the quotient of the leading coefficients. That's going to be 2 over 1, so y is equal to 2. Vertical asymptotes, anything that makes just the denominator equal to 0. Now notice here, you would usually say, okay, negative 1 and negative 2, but in this case, negative 2 makes the numerator 0 as well. So in this case, you only have a vertical asymptote at x equals negative 1. That's the only one that makes just the denominator equal to 0. So what about the one that shows up in both the numerator and the denominator? That's going to indicate a hole. So there is a hole at x equals negative 2. The y-intercept, we set x equal to 0, So plug 0 in, and we have 12 over 2, which is equal to 6. And then x-intercepts are anything that make just the numerator equal to 0. So in this case, x is equal to -3. Remember that at -2 we have a whole, so there is no x-intercept at -2. All right, let's put everything we have so far onto our graph. So we have a horizontal asymptote at y equals 2. We have a vertical asymptote at x equals -1. I will go over what to do with the whole in just a bit. We have a y-intercept at 6. And we have an x-intercept at -3. All right, you can feel free to create a table to get more points. You may also be familiar enough, having done so many examples now, to be able to draw a good sketch of the graph. Right, we know that the horizontal asymptote shows you what's happening at the far ends of the graph, so it should be very, very close to that horizontal asymptote on the far right and on the far left of the graph. And then you want to make sure you include the points that we already have on there, and then get very, very close to the vertical asymptote as you get closer and closer to -1. Now, if you still want to, you can feel free to create a table. So say we want to know what happens at -4, plug that in. We get y equals equal to 2/3, so that's about 0.6. -5, we get 1. Plug in -6, we get 1.2. So now you can see how it's getting closer and closer to that horizontal asymptote. Now let's go on the other side. So when x equals 1, we get y is equal to 4. So it's decreasing here. When x equals 2, we get 3.3 repeating. When x equals 3, we get 3. And so again, you can see as you get further and further away, you are getting closer and closer for your y value to 2. So plug 4 in, and we get 2.8. Now we can put those points on. So -4, 2/3, -5, 1, -6, 1.2. And then we have 1, 4, 2, 3.33, 3, and 3, 4, 2.8. And so now you can draw in the sketch of your graph. And then the last thing, which we haven't taken care of just yet, is the whole. Now for the whole, at x equals -2, if you have a good sketch of the graph, you can draw the whole at x equals -2 on your graph. If you want to be more exact, you want to go back to your factored form, and you want to cross out the x plus 2's, and you want to plug in -2. So when x equals -2, without the x plus 2's being there, you would have 2 times -2 plus 3. So we have 2 times 1 on top, so we have 2 in the numerator. And in the denominator, we have -2 plus 1, which is -1. So we have 2 divided by -1, which is -2. So the whole is at -2, comma, -2. So we can go ahead and draw that right in here. At -2, -2, there is your whole.